Hi, my name's Bob Sottilare. I hope at some point in the future they'll be able to present face-to-face. My talk today is focused on adaptive instructional benefits, challenges, and solutions. AI is playing a large part in automating various steps in the adaptive instructional process to support intelligent tailoring of learning experiences. So I think it's very relevant to the AAAI community. Thank you to Dr. Liu for inviting me to talk. I hope what I have to say will stimulate your ideas, enhance your understanding of adaptive instructional research, development, and also the marketplace. So thank you in advance for your attention. Here's the agenda that I put together for this talk. My goal here is to provide you with information, whether you're new to adaptive instructional systems or you're well aware of it, to be able to present to you and give you something that you can latch onto and take away from the talk. And so the agenda is set up to hopefully do that. We'll start off with an introduction. I'll talk a little bit about myself, my company, and my role in what's called the Adaptive Instructional System Consortium. I'll talk about adaptive, adaptable, and self-improving systems. And then we'll talk a little bit about adaptive instruction and what it is and how it's different from other less adaptive instruction. What adaptive instructional systems are, different categories of them, a little bit about enabling and emerging technologies, next steps for the AIS community, where do we go from here, what are our needs, what initiatives are we engaged in at this point, and then where the AI community, AAAI and folks in this community, where they can help. And there's some interesting challenges. So glad to be sharing those with you, and hopefully this will meet your needs, and I hope it will. So here's a little bit about me, my background in learning sciences, Director of Learning Sciences at SOAR-Tech, Chairman of the Board for the Adaptive Instructional System Consortium, which I'll talk to you a little bit more about in the next slide. As I noted in my introduction, I'm the Director of Learning Sciences at SOAR Technology. SOAR-Tech is an AI company that conducts research for the U.S. Department of Defense and was established in 1997 by Professor John Laird and other members of the AI Lab at the University of Michigan. As I mentioned, I'm the chairman of the board for the Adaptive Instructional Systems AIS Consortium, which is a nonprofit alliance under IEEE ISTO. We just formed in December 2020. We're a not-for-profit business association who promotes the development and adoption of effective AIS solutions. And we're there to support industry and organizations that produce adaptive instructional systems, components, features, etc., any kind of enabling technology. And our members are industry and academic organizations from North America, in Asia and the Pacific, Europe, and also in the Middle East. So if you're interested in joining the consortium or just want to know a little bit more about it, feel free to email me at bob.sottilare@IEEE.org. Thank you. Okay, so as we are getting into our discussion, one of the things I wanted to start off with is to talk about some differences and similarities between adaptable, adaptive, and self-improving systems. And so I think this is worth a minute or so to talk about. So adaptable systems are systems that are generally changed by their user. There's flexible control of information within the system. So an example of this might be your smartphone, right? You change what apps are on it, how it's configured, what it looks like to meet your specific needs. doesn't change itself, right? It's not an intelligent thing. So unlike adaptive systems do possess the intellect to change and act on their environment in response to changing sets of conditions. And then finally, self-improving systems are adaptive systems that perform better with increased experience, right? So they adapt themselves, but they learn over time based on the weighting of their decisions and to be able to improve their policies over time. Okay, so it seems like it's now good a time as any to define what adaptive instruction is. It's any training or educational experience that's tailored to the attributes. That means capabilities, needs, interests, preferences, things like that of an individual learner or a team of learners with the goal of optimizing the efficiency and effectiveness of their learning experiences and being able to transfer the skills that they develop in the training to operational or work environments. While we're focusing mainly on machine-based tutoring in this talk, adaptive instruction is often a technique that's used by expert human tutors, and key triggers for adaptations by machine-based tutors include modeling the understanding or learner competency, understanding what the gaps in their learning are relative to learning objectives, their preferences and interests, and of course, their overall learning goals. Adaptive instruction has been widely applied and highly effective to support learning of cognitive tasks like problem solving and decision making, where the measures of performance include accuracy of recall and understanding of processes. It also has been applied to psychomotor tasks like physical kinds of tasks like marksmanship, where measures of performance include like speed and stamina, accuracy, strength, agility, precision, and also for group tasks or team tasks, right, where people have different roles and responsibilities, and there's an interdependency of action and interaction within that particular team. Okay, so let's talk a little bit about characteristics of good instruction. Adaptive instruction is often touted as effective as expert human tutors in delivering and managing instruction. Good instruction can be measured in 3 ways, probably in more than 3 ways, but these are the 3 that I've chosen to focus on. Individualization, which is a measure of efficiency. The instructor, whether it's human or computer-based, tailors the learning experience to fit the individual learner. Immediacy, a measure of responsiveness, in which the instructor provides timely, relevant, and credible feedback. And then interactivity, which is a measure of engagement in which the instructor is actively engaged with the learner and the learner with the tutor. And these 3 characteristics, individualization, immediacy, and interactivity, are terms that are often used by learners to describe their adaptive instructional experiences. So next I wanted to talk a little bit about influencers of effective instruction. These are things that have largely to do with the learner, but also with the system that's still delivering the instruction. They include learner memory, the accuracy of modeling the learner in terms of their states and traits, right? So the system is trying to adapt to that particular learner. So if it has an inaccurate model of the learner, the decisions that it makes are going to be less than optimal. And then social and emotional skills of the learner, their ability to tough it through some confusing and frustrating sessions where their learning might not be going as quickly as they would like, And then finally, measures and the assessment of the learner. So how accurate are the measures of what they've learned, right? And then what's left for them to learn. So I'd like to just take a moment to talk about the needs of modern learners. There's always a discussion about how differently modern learners have evolved. I'm not so sure that we're wired any differently today than maybe learners 100 years ago. The environment, their knowledge of what their goals are, how much time they have available for learning definitely makes a difference. And so the system should be designed for speed and engagement, shorter lessons, micro learning, things that are within the sphere of interest and within their goals. Visual as media in terms of, based on the proliferation of, visual media that's available to us today on the internet or through, streaming services. So that is just what they're accustomed to looking at. Um, we need to be able to curate mobile compatible media, and so to be able to get that burst of micro learning on their smartphone is certainly an important element in making learning content available and accessible. And then finally, social aspects of learning. Today's learners tend to do things more in collaborative or project-oriented teams. And so that's going to be important to be able to distribute and have that be interactive and so that they can learn together. So we've talked a little bit about adaptive instruction, and as we're leading into talking about the technology of adaptive instructional systems, one of the things I wanted to mention was, how do instructional systems today work, and whether they're, human to human tutoring or machine to human tutoring, they work in a similar way if they're not very adaptive, right? Most of the systems have a single learner. There's some instructional system that provides content. The learner acts on that system, solves problems, reads material, completes actions assigned, and then then the learner kind of observes, okay, this is what's going on in terms of my learning. There's some kind of feedback. And the system interacts with the learner, assesses their performance, and then decides, okay, what problems to issue next. And so this is all, pretty standard in terms of presentation of content. And all the adaptations are really based on the learner's performance. Engagement is usually not a measure of instructional effectiveness. And generally, learners with the same level of performance receive the same identical feedback and instruction. And so there's no tailoring. There's nothing to take into account the learner's interests or preferences or what they've learned previously. It's not modeled in most systems. So in the last slide, we indicated how learners and instructional systems typically interact. So I wanted to talk a little bit about how adaptive instructional systems interact. What are the adaptations that the system provide to the learner, and what kind of interventions, whether that's feedback, etc. And so I thought I'd talk a little bit about how the system acts on the learner, how the learner acts on the instructional system, and how it acts to modify the instructional environment, and then a little bit about how that feedback loop works and self-improving systems, and how the adaptive instructional engine gets updated, right? So in terms of acting on the learner, so the instructional system provides some feedback, maybe asks a question, could prompt the learner for more information, could prompt them to reflect, could conduct an assessment at some point and decide whether they're at expectations, below expectations, or above expectations. So in terms of acting on the instructional system, all right, the environment in which the learner is interacting, the adaptive instructional engine could modify the challenge level. That's the primary focus of what the adaptive instructional engine is doing. It's trying to figure out, hey, is the level of difficulty in this problem space, is the learner equal to that task? Do they have the capability to do this, or is it well beyond them, or is it just too easy? And so as it observes the learner, it can make decisions about what to do and modify the challenge level. And then it can also select new content, right? So it could change content, move in a different direction based on its assessment of the learner and the learner states. And then finally, it acts on itself in that it observes what happens with the learner after interventions happen, whether that's feedback or support or direction, what have you, and then decides whether or not that those interventions were useful to the learner in optimizing their learning. And if it observes that it is a good thing, then it'll maintain the policy that it used, and if not, then it may decide after a number of decisions to make a policy improvement. Okay, so there are some advantages to adaptive instruction, and they do contribute to good instruction, right? So adaptive instruction provides personalized attention, customized pace, encouragement during one-to-one instruction. It adapts to each learner's abilities. It's equivalent to expert human instruction as measured by learning effect and learning efficiency. And so the ability to learn the same amount of material in a shorter amount of time or to accelerate your learning is an important feature or set of features for adaptive instructional systems. Adaptive instruction enables more efficient personalized learning by tailoring the learning paths of any particular learner based on their prior knowledge and their competency. It provides more focused interventions that target gaps in each learner's knowledge, individual's knowledge and skill in comparison to the individual's learning goals. The system uses adaptive instructional techniques to help develop the learner's metacognitive skills, resulting in better study habits, higher engagement, achievement. By reinforcing metacognitive habits like note-taking, reflection, or thinking aloud. Ask more questions. So successful students ask many more questions than unsuccessful students in one-to-one tutoring. Encourages students to ask many more questions. So we've spent a little bit of time defining what adaptive instruction is, compared and contrasted adaptive systems, adaptable systems, self-improving systems. We talked a little bit about characteristics of what makes good instruction. We reviewed some advantages of adaptive instruction. And so I think we're at a point now where I'd like to talk to you a little bit about what processes are available for effective adaptive instruction. And this is one process that I'm sharing with you. There are many different kinds of processes and the way systems interact now. And the effectiveness of those can be measured. So for this one, this is more about the interaction between the learner and the system. And so I'll take you through the 5 steps here now. So the system interacts with the learner and updates the learner model as changes occur in the learner's states. And those could be performance or emotions or engagement, anything that might influence learning outcomes. And then the next step, the instructional system selects some strategy or recommendations based on the learner's states and learning science principles about how people learn. And there's a whole litany of literature that can support that. and different systems use different learning science models. And then in the step 3, they select instructional tactics or actions that are specific to that domain of instruction and based on, again, learning science principles that are instantiated as policies. And they take into account what the context is, right? What the difficulty level and the conditions are of the learner and the learning path. And then they repeat steps 1 through 3 until the learning goals are achieved for that course or lesson. And then they document the achievements for use in subsequent instructional experiences or in some kind of after-action review. And that is the 5-step process. Okay, so after all that discussion about adaptive instruction, let's get into more specifics about what adaptive instructional systems are and how they deliver instruction. And so adaptive instructional systems are kind of 3 things, right? They're a set of instructional methods, right? So they deliver content in a specific way. Think back to this just previous slide for the process for effective adaptive instruction. And then there are a set of technologies, obviously, right? Computer-based systems that guide learning experiences by tailoring instruction and recommendations based on the goals, needs, and preferences of each learner. And then finally, they're products, right? They're actually things that are sold in the marketplace or some enabling technologies or models or methods. And so they use AI and other advanced technologies to help people learn. Okay, so in a nutshell, AISs are artificially intelligent, they're computer-based, they guide learning experiences, they tailor instruction and recommendations. They do this based on their goals, the needs, preferences, and interests of the learner, whether it's an individual learner or a team. They do it in the context of whatever the domain or topic learning objectives are and how they're defined. And hopefully they provide easy to use methods for authoring lessons and curating, searching, finding, storing, tagging, and retrieving content. Okay, so there are some common elements that are part of adaptive instructional systems. Pretty much every adaptive instructional system has these 4 elements. They might label them slightly differently. Learner model or student model, sometimes it's called, is a basis of tailoring. Instructional models. These are strategies and policies that are used in order to define learning science content and help the instructional system make decisions about the learner and the content. The domain model, it's about content, and content includes lots of things. It's not only about the information that's presented to the student, it's also any questions that are asked and any strategies that are or rules that are associated with a particular domain, so learning principles that are associated with that particular domain. And then it's also the interface model. So it's how the learner accesses and interacts with the system and how adaptations are affected by the instructional model. So at this point, we're going to switch gears a little bit and talk about the learning effect model. And the focus of this slide is to highlight what the process is for adaptive instruction and how it actually works with the learner. And so this is something that a model that I came up with in 2012, and it's been refined over time for both individuals and for teams. Measures are used to assess learner progress towards a set of defined objectives using learner data, which includes information about the learner's behaviors and their interactions. Measures and machine learning classifiers are used to determine learner performance and infer future performance. Accurate assessments of the learner's states, whether it's performance, emotions, engagement, are used to determine what interventions the AIS should select. These AIS interventions include feedback, support, guidance, direction for the learner, and may also include changes to the learning environment, the difficulty level, in order to match that to the learner's current capability. There's this continuous monitoring that goes on of the learner states to help model the effectiveness of the AIS interventions in terms of learning outcomes. These include learning, which is knowledge and skill acquisition, performance, retention, transfer of learning from the training or educational environment into some application, a work environment, and then effectiveness measures help improve the selection of future AIS interventions and reinforces the AIS's capabilities. And this is the learning effect model. So there are lots of different adaptive instructional systems. So they're kind of bound into 3 different categories. One which we call intelligent tutoring systems, and one that is a set of recommender systems, and then something that is a catch-all that's just called intelligent media. So intelligent tutoring systems kind of, this kind of standard interaction that happens in training and educational environments. They could be dialogue-based tutors, example tracing tutors, model tracing tutors, cognitive types of tutors, constraint-based tutors, lots of different kinds. And we'll talk about some of the architectures in the next few slides. Recommender systems are typically things you're familiar with, like expert systems that have kind of rigid decision trees based on what your input is, depends on where you go in the tree. And then you have something called intelligent mentors, which assess the condition of the learner, what their goals are, etc., make recommendations about what to do next. And then, like I said, intelligent media tend to cover things that are not covered in the other 2 categories. So those are categories of adaptive instructional systems. We talked a little bit about the effectiveness of adaptive instructional systems and adaptive instruction and regular instruction and how they differ. So I thought it would be good to look at salient characteristics of adaptive instructional systems. And this is adapted from a paper I did with Stephen Gilbert at Iowa State in 2011, 10 years ago now. And the list is pretty much the same. There's a couple of additions, but basically effective adaptive instructional systems are self-improving. They're adaptive, obviously, that they tailor instruction to the needs of that particular learner or team of learners. They're effective and credible, just like any tutor. They provide relevant information, and they're able to support instruction in both ill-defined and well-defined environments, based on the learner's goals. They're accurate and valid, right? So they use optimal instructional methods based on empirical results. They're usable, right? They're easy to use. They're accessible, practical, and affordable, right? And they're persistent in terms of modeling the needs of learners across lots of different instructional experiences and cut across their careers or even their lifetimes. We talked about categories of adaptive instructional systems. I thought I'd touch on a few architectures. There are 5 that are listed here. I'm not going to read them out, but basically there are many, many more. Some of them are very generalized in terms of their application to many types of instructional domains or topical areas. Others are very narrow in terms of what they do, but they have very comprehensive authoring systems to develop content and to develop courses. And and so they kind of run the gamut. And so let's talk about a few of them. So the first one, adaptive instructional architecture that we're going to talk about is Tutor. You can find out more about it at www.autotutor.org. Tutor is a tutoring architecture used to develop intelligent tutoring systems that guide instruction through conversations with learners via natural language interaction. And so AutoTutor has been applied to lots of different cognitive domains and produce learning gains across those domains that include computer literacy, physics, critical thinking, etc. Uses human-inspired tutoring strategies in terms of question asking and reflection. Interacts with pedagogical agents to track and guide learning. So if you look at the bottom left, you see two starry-eyed virtual characters. The female is the teacher, and the male is on the right-hand side of the picture is a fellow student. And so as a learner, you have the option of interacting with not just the tutor, but also a fellow student. And this has been highly effective in multiple domains. In discussing AutoTutor, I thought it would be useful for us to talk about what makes effective dialogue-based instruction. And so just as there is a 5-step tutoring process, there is also a 5-step tutorial framework that is focused on dialogue-based instruction and how to deliver that effectively. And so we'll just hit the highlights of this. Basically, step 1, the tutor asks the learner a question. The learner answers the question, and then the answers evaluated by the tutor, and then the tutor proceeds to answer with some elaboration, right? So the answer is elaborated primarily by the tutor, some extent by the learner to improve the quality of the answer to that particular question. And then finally, there's an assessment of the learner's understanding as they improve the answer over time and finally get to a level of proficiency in terms of understanding the concept that's associated with that particular question. So next, we're going to talk a little bit about the cognitive tutor. It's a tutoring architecture used to develop rule-based and example tracing intelligent tutoring systems. And so the assessment of whether the learner is progressing towards the level of knowledge that's required is determined by some tracing of an example that is a process which the learner is supposed to be able to follow, and focused on cognitive tasks, mainly problem solving and decision making. Produced learning gains across multiple domains: computer programming, physics, chemistry, thermodynamics, etc. Been around for a very long time, very detailed. Has made the transition to commercial product through Carnegie Learning, which is a commercial company, an offshoot of the Carnegie Mellon University project that started as the cognitive tutor and now is sold as a product called Mathia, M-A-T-H-I-A. Okay, so the last tutoring architecture that we're going to touch on is the Generalized Intelligent Framework for Tutoring, or GIFT. It's a free, modular, open source tutoring architecture. Again, has produced learning gains across cognitive, psychomotor, and team instructional domains. Been applied to medical tasks, marksmanship, human anatomy, land navigation, or orienteering in the civilian world. Was developed by the U.S. Army. Supports rapid authoring, reuse, and interoperability of tutors across the instructional architecture. So it's been around not quite as long as Cognitive Tutor or Auto Tutor, but has been around now at least in its current form, for at least the last 6 or 7 years. And it's learning tools interoperability compliant, so it's been used to stimulate like edX courses, transparent to the user, to be able to provide adaptations or recommendations about what that particular learner should do next. And so pretty comprehensive, has a set of authoring tools, has a real-time instructional system, interactive model, has a evaluation. You're able to build experiments based on courses that you build and collect data and format and report that data. So a great research tool also. So I encourage you to check it out at gifttutoring.org. Okay, at this point in the presentation, I thought it would be useful for me to talk a little bit about AIS enabling and emerging tech. I wanted to do that in the context of how adaptive instructional system architectures work, and specifically, thinking back to Auto Tutor, Cognitive Tutor, and Gift as instructional architectures, and how does enabling and emerging tech support those architectures? Because not everything's a system. Sometimes it's a feature or a tool or a method. And so there are enabling tech out there and emerging tech. So I want to do that in the context of how you might think about the instructional process as you're building it. If you're an instructional system designer or a course manager for an organization, you would plan the instruction, prepare the instruction, execute the instruction, and then evaluate the effectiveness of the instruction. And so I want to touch on tools associated with those areas, and so we'll hit a few of those. In the planning phase for adaptive instruction, an important piece is knowledge management, right? Being able to understand what learners in a given field need to know, the ability to model different learning paths to reach various levels of competency, ability to define learning objectives tied to specific activities, to grow knowledge and skill in that particular domain. The ability to identify measures of assessment to track learning and growth, the ability to manage data, to model changes in learner competency, whether that's in real time or across many learning experiences, a career or even a lifetime. And then finally, the ability for learners at all competencies levels to be able to publish their knowledge, right, and to share their knowledge so that, again, we have some understanding of what the standards are in a particular area, what expectations are, and are able to manage that knowledge and use that in the future for building courses. So I've got this kind of red light, yellow light, green light methodology. I would say at this point in time, knowledge management tools related to adaptive instruction are probably yellow. Why there are many good knowledge management tools out there, lots of commercial management tools. They're limited in their ability to automate processes, so the workload required to set them up and use them is relatively high, and that's why I have them as yellow. So in the preparation phase of adaptive instruction, what we're doing is we're creating courses or authoring courses or lessons or scenarios. And then we're also curating content, right? So we're out there searching for content, maybe developing some content, tagging that content, etc., and then storing it for later use. And so authoring tools are, again, used to help define objectives and assessment methods, to develop adaptive scenarios, courses or lessons, to integrate external systems, right? So it might be that you have a simulation that's not highly adaptive, but you want to drive that with an adaptive instructional system, and this has been done many times before, and especially in game-based environments. to get the engagement of a game and the usefulness and the rigor of an adaptive instructional system. And content, content curation. Again, you're constantly kind of surging for content, tagging that content, storing it, and retrieving it. And again, I've used the red, yellow, green. Again, I've had this category yellow. One reason is authoring tools are not always part of a given adaptive instructional system architecture. Or if there are authoring tools, they're not very user-friendly. Commercial content curation tools abound, lots of them that are focused primarily on social media and marketing, and may not be as effective for selecting content for use in adaptive instructional experiences. So in the execution of adaptive instruction, this is the real-time interaction between the learner and the system. It's important to make sure that you're adapting the learning experience difficulty to closely match the capabilities of the learner. This is a theory that was developed by somebody called Vygotsky, and it's called the zone of proximal development. I'll talk a little bit more about that in the next slide. Real-time assessment is important. Again, this interaction needs to be, if it's a dialogue-based tutor or if there's some training interaction, this real-time piece is really important, so as not to disconnect or interrupt the flow of that particular learner and their learning experience. Relatively accurate assessments given there's enough data, so that's kind of where the technology is. Still need unobtrusive methods to accurately assess things like emotion. There's been lots of experimental methods that have been used to wire people up and assess them. So being able to do that with some unobtrusive, low-cost sensors like webcams, etc., is useful in maintaining the accuracy of those methods as the learner moves around, specifically for like psychomotor tasks. That's important. And then this idea of real-time optimization, insufficient data from across learning experiences to generalize methods that optimize instructional interventions. And so this idea of building competency models and maintaining those models across different instructional experiences is important because, again, most people are using multiple systems. They're not just using a single architecture. And so there's quite a bit of research and development going on to develop standards to be able to do that real-time optimization. So I had mentioned the zone of proximal development and being able to connect the difficulty level of the problem or scenario or learning experience to the learner's capability. If there's too big of a disconnect, then this creates some emotional changes. If you have a high level of challenge and a low level of competence in terms of the learner becomes very anxious. If it's too easy and they have a high level of competence and the challenge level is low, they become bored and disconnect. And so this monitoring and managing this interaction with between the learner and the adaptive instructional system is an important element of the architecture. So, and finally, I thought we'd talk a little bit about evaluating AISs. I could have rated this as a red light, but I thought since there are a number of initiatives that are going on now, it would be worth putting it as a yellow, and then kind of taking you through what's going on. There are a number of IEEE standards that are related to adaptive instructional systems. There are two active groups that are going on under the Learning Technologies Standards Committee. One is 2247, which is specifically adaptive instructional systems, concept models, interoperability, evaluation methods, protection of data, ethical use, etc. And another one is 9274. That project is focused on using the Experience Application Program Interface, XAPI. Those are achievement statements that are generated by adaptive instructional systems and used by competency modeling systems in order to assess learning over longer periods of time than a single lesson or session. And then lots of activity going on within the AIS Consortium. But one thing worth noting is there will be some evaluation certification services that'll be developing over the next year or so that will match up with the IEEE standards that are evolving at this point. And so this will be one way to certify some minimum interoperability or effectiveness of a particular system, and that'll give consumers pretty good warm and fuzzy about where those systems are going. There are a number of competency modeling tools that are out there. They're pretty limited at this point, but evolving. Credentialing tools also growing. There's a number of services that are out there that are supporting different states, counties, and federal services. And then self-improving system architectures, I'd have to say those at this point are very limited. And I think as we see more implementations, then that will help us in terms of where we need to go, what standards need to evolve, and what are recommended practices for self-improving system architectures. So let's talk a little bit about next steps. As I mentioned, the AIS Consortium, very active. We have a resource repository that's going to start up here soon. It's going to be focused on open source, at least initially, with some reference implementations that'll be available to members as those are built out. But the actual projects that are migrated to the repository in 2021 will include GIFT. So GIFT will be available, and you will be able to not only use it, but actually modify it and use it to build other products. That has been limited to this point, but now it's a truly open architecture. Competency and skills system will also be migrating. So this is a competency modeling and credentialing process, and so that will get us started, and hopefully the people who are using the system will be able to contribute back to it and improve it. Guru Navigator is another project. This is an open source visualization to support open learner modeling, so learners can actually see how they're progressing and take a little bit more initiative in their learning, and so that will be part of it. And then the repository will be LearnSphere compliant. That's important. This is a way of storing and sharing learner and system data. It's going to be important for the AIS Consortium and really for the AIS community as a whole. We will have some, as I mentioned, some reference implementation projects that'll happen later this year and in 2022. And so an example would be some exemplar courses in cognitive psychomotor and collaborative learning domains that are GIFT compliant. So that is what we have going on in terms of next steps in the community. Okay, so reaching out to the AI community as a whole. Here's where the community can help in terms of developing tools and pushing the state of the art forward and moving things from the state of the art into state of practice. And so the thing that's on the top of my list is, grassroots knowledge sharing tools. As I mentioned, there are a number of commercial tools. It'd be nice to have something that was particularly focused on adaptive instruction and the processes that we use, and so that people who are knowledgeable in the AIS community can share their knowledge. The next thing is AI-guided authoring processes, and authoring tools at this point tend to be difficult to use. It's sometimes hard to follow where you are in the process. Gift has some really nice drag and drop tools. They're super great, but there's really not any kind of even checklist. Although there is a validation when you get ready to go publish your course, whether or not you have all the information in order to be able to do the assessments that you laid out in support of learning objectives. So something that was AI guided that would remind you or guide you through the process to make sure that the process is complete, rather than just at the end when you go to validate here that you didn't do what you were supposed to do. Enhanced authoring process automation to reduce workload. These systems are multidisciplinary kinds of efforts, with instructional designers and computer programmers and psychologists and and learning scientists, etc. And so it's sometimes difficult to build these systems without a whole lot of knowledge. And so if you happen to be a subject matter expert, somebody who knows about a particular domain, the goal for these systems is for you to be able to build the system without any knowledge of computer programming. And so we'd like to see enhanced authoring process automation to reduce the workload and kind of ferret out some of the tedium that's associated with building these systems. Areas that can be useful are automated scenario generation, so that you can have lots of different but equivalent kinds of scenarios that can support learning in a particular domain. And then automated hierarchical text mapping to domain topics, so to be able to define learning pathways. Lots of texts that are out there, right, in terms of books. Or even if they're electronic books, is to be able to take those things and to automatically map those into topical areas and plot out paths from very novice learners to very expert learners. And next thing on the list is more robust content curation for learning experiences. Is to help with automating those processes. Maybe auto tagging, metadata tagging would be useful. And then more robust low data methods to support things like learner classifications, assessments, bootstrapping of goal-based policies. Hey, how do you start out, when you're authoring new policies? How do you know what's most effective? And you don't want learners on the front end to get, to be denigrated by poor policies, right? So how is it possible to bootstrap some of those goal-based policies? Optimizing AIS interventions, right? And so this idea of, hey, I understand what's going on with that learner. What's the best thing that I can do for them? And I would say that it's that's not crystal clear yet. And then more robust, unobtrusive assessment of emotional states. So emotions really play a large role in adaptive instruction and in learning processes. And so being able to track those things, but do that in a way that doesn't interrupt flow or influence or create frustration, frankly, for the user. And so that's what we have and what we're asking for from the AI community. Okay, so we're at the end of our talk, and I really appreciate the attention. I know it might be difficult given the the dispersed, distributed nature of the talk, and the fact that I'm not there during the replay. But I hope this will at least have given you an introduction to some of the challenges, some of the needs for adaptive instruction, adaptive instructional systems, and their architectures. So thank you very much for your attention.